Bonjour, baddies. Welcome back to another video. Today's first question is, in the diagram below, we have ray OW is perpendicular to ray OY, and ray OX is perpendicular to ray OZ, which I've already marked out. Oh, the 90-degree angles, I mean. If angle WOZ is 5 times angle XOY, then what is the measure of angle XOY? If we look at this picture, you can kind of see two not very distinct, but relatively distinct right angles, and they're two different ones. There's the WOY, so I'm just going to highlight this real quick. This funny looking right angle. And XOZ, which is this right angle. So now that I've highlighted it, you can kind of notice that the area in between these two in which they're overlapping just so happens to be XOY, which also just so happens to be the thing that we're trying to solve for. So only if we could turn WOY on its side, so we would get a perfect 180-degree angle with the two right angles, and our XOY wouldn't be overlapping anymore. That would be so easy to solve. Well, technically, we can. So if I take this silly little arrow here, if we turn W so that it basically touches the ground, let me just draw this out. So if we basically turn it like so, and if this point basically becomes the new Y, and this point basically becomes the new W, then our XOY isn't overlapping anymore. And we have a perfect 180-degree angle, which is basically another number. Woohoo, numbers are easy to work with. So, using this idea, you might be like, oh, well, then they wouldn't be equivalent, like the total angle anymore, right? Well, technically, they aren't equivalent anymore, but this little bit, their angle measures are still same, like individual angle measures. But this little bit, since it's the two right angles spread out, and it's a straight line, it would be 180 degrees. Therefore, we still have a number to work with. So, using the information that angle WOZ is 5 times angle XOY, we will get something similar to this, since the area that we spread out is equivalent to angle XOY, because we basically got rid of the overlapping part. So this means that this is WOZ, this is XOY, therefore 5 angle XOY, aka WOZ, plus angle XOY is equivalent to 180 degrees, or our straight line. So 6 angle XOY is equivalent to 180 degrees, or angle XOY is equivalent to 30 degrees. Therefore, our final answer is 30 degrees. Moving on to problem number 2. What is the number of degrees in the smaller angle between hour hand and minute hand on a clock at 8:30? So, as you guys can see, I've basically already drawn out a simplistic clock for you guys. And since it's 8:30, our hour hand has also moved halfway through the hour gap. And I've done something similar to this in a previous video, but in case you guys haven't watched that yet, since the total inner degrees of a circle is 360 degrees, and there are 12 technically hour gaps within the circle, we can go 360 divided by 12 to figure out how much is in each one of these gaps. AKA, there is 30 degrees, technically. So, taking that idea into our current problem, between our hour hand and our minute hand, there are 2.5 hour, quote-unquote, hour gaps. 1, 2, and there's a halfway partial one here. And since each hour, quote-unquote, hour gap is equivalent to 30 degrees, this means that we have 2 30 degrees to work with just the 2 hour gaps. But you might ask, oh no, but the last one, it has 30 minutes, so how are we going to incorporate that into degrees? Since it's half of the total 30-degree gap, this means that it's only 15 degrees because, it's perfectly halfway there. It's 8:30. Therefore, we just add on a 15 degrees, aka 30 divided by 2, in which we then get a 75. Therefore, our answer for this problem is 75 degrees. So yeah, that's the end of this video. I hope you guys enjoyed it, and I hope you guys learned something new. And I will see you all on the next one. Bye-bye!